Hello coders, welcome to Level Up with Coding. Today I will be solving the problem 786 k smallest prime fraction. Let's understand what the problem is. You have a given an array of integer where the first number is always 1 and the other's number is always prime. And you have to return the kth smallest prime fraction. Kth smallest prime fraction means if we choose two integer I and j, which will be the indexes, and a of I by a of j is one of my prime fraction, and where I should be less than j. Okay, so you have a given an array, we have to return the kth prime fraction, and where prime fraction means a of I by j, where I should be before j. In the first example, all prime fractions are like 1 by 2, 1 by 3, 1 by 5, 2 by 3, 2 by 5 and 3 by 5. But what we have to return? We have to return the third smallest prime fraction. What is the first smallest prime fraction? Among them, the 1 by 5 will be the first smallest prime fraction, and the second will be 1 by 3, second will be 1 by 3, and the third will be 2 by 5. So as the third is 2 by 5, so for that case we have to return 2 and 5. That means we have to return the smallest prime fraction values, that means which result in the kth smallest prime fraction. For that case 2 by 5 gives me the third smallest prime fraction. So that's why we have to return 2 by 5. So how we can solve the problem? First we generate all possible pair. Like for the first example, we generate all possible pair like 1 and 2, 1 and 3, 1 and 5, then 2 and 3, 2 and 5, and 3 and 5. Then what we can do? We can use an priority queue. Why priority queue? Because we have to return the kth smallest, and we store the all fraction in a priority queue so that we can able to find the kth smallest. How we store the priority queue? We'll take three parameter as in my priority queue. First will be my fraction value, second will be my first index, that means I, and third will be my j. Like for the first example, my priority queue inserted value will be 1 by 2, comma 0 and 1, because this is the fraction value 1 and 2, and 1 is present in index 0, this is I, and 2 is present in index 1, this is 1. In this way we push all the pair in priority queue. Then we remove first k minus 1 because we sort them at mean heap. That means the first will be the first smallest, second will be the second smallest, third will be the third smallest, in this way. But what we have to return? We have to return the kth smallest value. So if we remove the first k minus 1 smallest value, then we can easily get from the top of the priority queue what is the kth smallest value. Then we pop up the kth smallest value, then we will get three values, right? One is my fraction value, one is my I, one is my j. Then what will be my answer? My answer will be a order of I, comma a order of j. This will be my answer. In this way we can solve. So what will be the time complexity for that case? Because we have to generate all possible pairs, so the generating all possible pairs we need n square, and as we using priority queue, it will overall take n square log n time and also n square log n space. So can you reduce the time complexity? Yes, we can reduce the time complexity, but how? So what is given in this problem? In this problem it is mentioned that the first number is always 1 and all the other numbers are prime. But another statement which is also included, that all the numbers is sorted in increasing order, right? That means the first number is always the smallest number and the right hand end number is always largest number. That means this is in sorted in ascending order. Okay, so can we say that my 1 by 5 always give me the first smallest prime fraction? Why? Because 1 is the smallest number and 5 is the largest number. So can I say that 1 by 5, that means the first element by last element always give me the first prime fraction? Yes, it is always true, because the first element is the smallest number and the last element is the largest number. So it will always give the first smallest prime fraction. But what will be the second smallest prime fraction? So second smallest prime fraction can be my 1 and 3, and also it can be 2 and 5, right? Because 1 and 5 is my first smallest prime fraction, and second can be 2 case. What will the second prime? It may be 2 and 5, and it may be 1 and 3. But for that case, 1 by 1 and 3 is my second smallest prime fraction. That means 1 and 3 is my second smallest prime fraction. Okay. 1 and 3 now my second smallest prime fraction. Okay. Now, what will be my third smallest prime fraction? My third smallest prime fraction can be 2 and 3 or 2 or 5, right? Because 2 or 5 can be, and now 2 or 3 also can be. So what we will be doing, suppose we have an array of integer like a1, a2, a3 and a4. So what we will be doing, we'll take an priority queue as a my mean heap. We take an priority queue as my mean heap. There will be 3 parameters. One is my value, one is my I and j. This is first index and j is second index. So what we'll be doing, we just push as a fixed a1 as a fixed, because this is the smallest value and this is the largest value. Okay. So what we'll be doing, we just push all the value like a1 a5, a1 a4, a1 a3 and a1 a2. But we know what is the smallest value, we can easily get it from priority queue. But for the first case, we can surely set this will be a1 and a5. Okay, and we can easily it also be we will get from priority queue. Okay, so if we get a1 and a5 is my first smallest fraction, what will be the second? The second can be a1 and a4. The second can be a1 and a4, or it can be a2 and a5. This is the two possible case, right? This is the two possible case. So what will we know? What will we know? A1 and a4 is already in my priority queue. So we just put a2 and a5. In this way, we can easily get the kth smallest prime number. Okay, suppose we get that a1 and a5, 1, 5 is my the smallest prime fraction. Okay, 1, 5 means a of 1 by a of 5. This is the smallest prime fraction. So what will be the second? Second can be 1 by 4. That means index 1 value or index 4 value or index 2 value or index 5 value. Right? In this way you can easily get. So what will be doing? We just push the next element and the last element for all case. Okay. So what will be the time complexity for that case? The time complexity will be order of max of n comma k. Max of n comma k. Because it may happen k is greater than n, right? Because there will be more than n pair, right? So this is the max of n comma k and log n. Okay, this is the time complexity and this is also the place complexity. Okay, and let's move to the code editor part so that it will be more understandable. So first we initialize a pair class because we have to use in my priority queue. So what will be the class? My pair class will be 3 attributes. One will be my double val, because this will give me the fraction. One will be the first, this will give me the first index of my fraction value, that means the first value, and second will be give me the lower value of my fraction. Then we initialize with the constructor. We initialize all the value with a constructor. Okay, then what we'll be doing, we just initialize a priority queue. Okay, as we mentioned, the priority queue will be based on the value, based on the fraction value. Okay, so we initialize a priority queue, and priority queue of pair. Okay, and it will be based on the fraction value. So if there is two such value, we will compare based on the first value. That means a of 0, b of 0. That means the fraction value we have. This is my parity cube. And what we'll be doing now, we'll go through that. As we mentioned, we first fix the first number and push all the others number in my parity cube. That means we push all the others number and fixing the first number. That means this will be, what will be my fraction value? My fraction value will be, first we have to convert in double, because this will be in integer division if we not convert in double. And then my first value always fixed, because as we mentioned, we first fix the first value, that means AR of 0, and push all the others value like AR 0 by AR of I, and then my first value is always 0 and the next value is I. This will be my first. We push all the element. And what we'll be doing until k is greater than 1. That means we need k. So we have to remove the k minus 1th term. So what we'll be doing, we just pop out all the elements before k. That means k minus 1 element we pop out. So this will give me the first element. That means what is the current smallest element? Current smallest will be given from the parity cube top, and we know the first index is t of first and the second index is t of second. This will give the current current element first index and second index. So what we will be doing, if we see that next element, that means the next element is not the f2. Okay, that means we push them. What we'll be doing, we just push them. We just push them in parity cube, and this will be ARR of f1 plus 1 by f2, and this is also will be f1 plus 1 by f2, because it is, I will mention it is, because I will mention that, because if we see that my current element give me 1 and 5, what will be doing, we just push them the index 2 and 5. Okay, right, it is not. But if we see that this is give 1 and 2, we can't push 2 and 2 because we not use same element. So that's why I am checking that is my current element plus 1 not equal to the second element, right? That's why I am checking. We just push them, and after that what will be my answer? My answer will be this will be my answer. What will be in the parity cube top? This will be my answer. But what will be my answer? I know the indexes of my answer, so we have to return the value also, right? So we will return the value. What will be the value? ARR of answer dot first, comma ARR of answer dot second, because we know the first index and second index value from the answer, right? So we just push, we just return the answer. Okay, and for that case we have to reduce every time the value of k. Okay, and let's run the code. There is a missing statement. Okay, sorry, I will not using any array. This will be my a dot val, and this will be b dot val, right? Yeah, it accepted, and let's submit the code. Yeah, it beats 68%. In case you like our video, make sure you subscribe the channel and stay connected with us.